So when
Who's
is
that talking?
Winston?
2C?
When was Winston supposed to land?
I don't know.
Or did they
I
have
don't,
somewhere where?
sir. You
Or did
really
they?
think they're bringing a flat earther to Antarctica?
I don't know. Want to see what's
Absolutely.
going on.
Absolutely. They're going to live stream when they do it.
Sweet. So, does anybody know if they have a tracker of where when what are they doing? Like when they're
Yes.
landing?
Yep. Yeah, you can go on MC Tune channel, and he has all the trackers for all the GPS trackers for everybody, or Duffy's channel, and you can get all the. He has all the trackers going, and you see everybody's at.
I've posted a couple of pictures over Lake Pontchartrain if anyone wants to discuss it, and I'll show to you like the reflected properties of light, why you can see certain buildings and not certain buildings. Even though the distance is the same to these buildings, there's three of them in this complex. One being the Marriott, and then the parking garage is associated in another building. And the one that's appearing to be floating in the sky at 42 after is part of that complex, but you don't see the other two buildings, and you don't see the building that's actually the tallest one. You see the one that's more directly at the angle of the viewer. And the reason is because the other two buildings are angled differently, and you're not getting all that information. You're actually not getting any of the information because you don't see the other two buildings at all. So there's three buildings there, but you're only getting the reflected light from one of the buildings, and it's miraged on this day to hell and back. But on different days, I'll pull up a picture. But on different days, it just looks obstructed bottom up, and on other days, you can see more of the building than you can on some. But it's just the way reflected light gets back to the viewer, and what information that viewer gets. However it works, I don't know, but in that picture where the Marriott, the building, that one building of the Marriott complex looks to be floating in the sky, it's also mirrored top to bottom. You don't see the other two buildings because they're at a different angle, and you're not getting that reflected light back to the viewer.
It acts exactly like you would say it does from the globe Earth model.
Yeah, except that the bottom up obstruction is caused by physical water and not refractive effects. I'm proven right here with these pictures that I've taken myself. That's how I've proven it to myself, that the angle and the mirroring and the reflection matters, because you have buildings at the same distance that you should be seeing that are not in this picture because you're not getting that information back to the viewer. So on this day, it's looming. It appears to be floating in the sky. And on another day, which I can post a picture of, I have many. The building is. I mean, I don't know how you're refuting when I haven't even said anything.
Oh no, I was going to go back to the other point. I had my doing something quick. I had to chime in. But go ahead. I'm sorry, I didn't mean to interrupt you.
Well, I'll post a picture of sinking refraction instead of looming. So it's the same building, but you're still not seeing the other two buildings that are next to it, even though they're the exact same distance, because they're at a different angle. So it's like if you saw this picture and I asked you how many buildings were at that same distance, you would say one. And that's just not the truth. You're being fooled. It's an optical illusion created by the conditions and the reflected light angles telling you there's only one building there, when you take a picture up close, there's obviously more buildings there, and you're just not seeing that. Your brain is tricking you.
Yeah, I got you.
Yep. So the picture that I posted at 40 after is me Friday afternoon driving towards the Marriott complex, and you can see there's three buildings right there in a group. The Marriott Hotel is actually the tallest one, but in the picture at 42 after, you're seeing only one building and it appears to be floating in the sky. And the taller building, which you should see, and the one to the right, which is the same height, you don't see because you're not getting that information back to the viewer. And then at 44 after, on a different day, you're seeing the building obstructed bottom up instead of floating in the sky because it's just a different condition, different day that has different conditions.
Yeah.
But even on this day, you're not seeing the buildings next to it, although they're the same distance, because the angle of those buildings are different. So the reflected light coming off of them are not reaching the viewer.
Well, I would just say that the simple fact of the matter is that if the Earth was flat, you wouldn't have to have any of that. You'd just be able to look across and see it.
No, bro, you would still. What are you talking about, man? This is what makes me like. Do you not get that you have refraction because you're how we see over distance, not because of the surface of the Earth? Like refraction has nothing to do with what surface is underneath you. It has.
I know you. I just said that's why I said you wouldn't need refraction. You wouldn't need refraction.
What are you talking about? Refraction would happen. It would cause these same effects over a flat plane.
Okay.
Well, hold on.
When?
What would you
Where?
expect?
At what distance?
What do you mean? I have it at 3 miles, and this is 24 miles. It happens at different distances. It just depends on the conditions. Yeah. Well, 3 miles.
I know, but you're saying. So, I know, but hold on, man. Let me get it out. Man. So with your rationale, you're saying that under ideal circumstances, which will happen, that's just mathematically the way it is. You'll have a nice day one day. You'll be able to see across that lake with no reflection on a flat Earth.
Yeah, I just wanted to ask you, bro, what would you expect to see on a flat Earth? Like, you think that you could see forever, infinitely, from one side of the realm to the other?
I didn't know across Lake Pontchartrain is infinite. That's pretty like big lake.
Like, you think you could see the Eiffel Tower from Boston on a flat Earth?
That's relatively the same size as Lake Pontchartrain.
I'm just wondering, like, what's in your mind? How do you conceptualize flat Earth, bro? Because apparently you don't really understand what would happen.
I know.
On an actual topographical plane. It would literally be like the same as what you see right now, dude. Because you have atmospheric conditions obscuring objects in the distance. And depending on the conditions of the day, you can see way farther than what your geometric horizon allows for. Which when we bring this up,
you just said we can't see forever though. Remember that. You just said we can't see far. You said we can see much farther than expected.
Right.
Oh my God, dude.
You can't see.
Well, you gotta be consistent. We were talking about Lake Pontchartrain. Now this guy brings up London from Boston or whatever. And the bottom line is just
he's asking you if you think you could see forever. You can't even see 24 miles.
Okay, well then how far is the sun and the moon?
Oh my God, bro!
I can see those. Those are pretty far.
Yeah, but it's all has to do with angles, dude. Angle measurement, right? So what the sun is a lot.
So as long as there's an angle, you can see far. How far can I see with an angle?
Right.
How far can I see with an angle?
Well, I'm trying to explain it to you. The sun and the moon, right? You have to consider their altitude, how high they are compared to things that are close to
then how high are they?
The
I asked you how high are they. I asked you that. How high are they?
I can only give you an estimation. I have no idea.
Then how can you make an assumption or make a fucking? What are you talking about? What are you doing? You're trying to say I don't know, but I know. But I know this. I know how far you can see. What are you talking about?
You get too excited, bro. What we're saying is if an object 3,000 miles away is at the surface, you're not going to see it probably because of the density of the medium, and it's going to be all refracted to hell. But if that same object, especially if it's a light like a strong light, let's use the sun, and it's at a different angle but at the same distance, let's just say 3,000 miles, when you couldn't see it at the surface level because of those reasons, you will be able to see it when it's directly over you because there's not that density layer obstructing your vision. Do you get that point?
Yeah, but then now we're back to that main point. What about the days when there is not that atmosphere obstruction? What about those days?
Then you still, no matter if the refractive effects are high on one day on another, of course they change. I'm showing that now, but the angle that you're looking over the surface when you're close to the surface also matters. So you get that.
Yeah, it's flat and level, dude. It's flat and level. If I'm looking across it, I should be able to see across it, no matter how big it is.
No, bro. Okay, hold on, dude. This is the thing you have to understand, right?
It's amazing.
The only way to make an object, right, appear again, that's at like it. what's the technical word? Dude, I can't think today. Resolve. The only way to resolve an image, right? That's at a distance, let's say of 4 miles, right? 5 miles, right? Is if you either A, get closer to that object, right? Reducing the distance to that object, or B, if you increase in elevation, right? By increasing elevation, you get a better vantage point. You get a better angle to the object, resolving that object, right? Regardless of atmospheric conditions. You understand that concept, the fundamental
Absolutely.
concept?
Absolutely.
All right.
So with that, how high do I gotta go from Boston to see the Eiffel Tower?
Jesus Christ. Well, okay.
It's not Jesus Christ. It's a real fucking question, dude. It should be answered easily for you guys.
All right,
you should know this.
So this is the problem, bro. Right? Even in ideal conditions, on a perfect day, you look up on the weather, it says high visibility, right? Green, awesome visibility. Even on a perfect day, you still have atmos to contend with. Just because the Weather Channel tells you you have high visibility doesn't mean that even on a flat Earth you can see forever. You still have water
you
vapor.
said with elevation. You said with
you-
elevation we
hold
can
on.
see further.
No, you still, yeah, even on a perfect day, just because you raise your elevation doesn't mean you can see forever.
Okay.
Just because
but
you
listen,
went up
this is a
35,000
mathematical.
feet,
Oh my gosh.
just because you went up 100,000 feet doesn't mean that you can see the Eiffel Tower.
It doesn't matter if this is a
I
mathematical
can tell
question.
you right now.
You can tell there's a mathematical way to tell the height you need to go to see over there, and regardless of weather. You don't put, it's a cloudy
No.
day though. It doesn't work that way. No, you have a
Dude,
height.
you are
need to go-
trolling, bro.
Yes, you do.
You're either
Yes, you
ignorant
do.
or trolling.
Rob, I go to the Weather Channel and look for the weather today
has
in your
nothing to do with
area.
weather.
Shut up and
It has nothing to do with
listen.
weather.
Shut up. I'm talking, dude. You don't just start talking over me. There's
one at a
it tells
time.
you it tells you the temperature, whether the high or low, humidity, pressure, and visibility for Houston is 10 miles.
I know.
So
Yeah, and
I understand
and
that, but
Lion's
I'm not
right.
talking
Lion's
about
right.
weather.
Hold on, Rob.
I just,
It's
let me
about
get
what
my.
light. Yeah, but
I
let
just
me
wanna
just
get-
help you put it into perspective for Lion. It's about the light you're resolving, bro. There's something called the inverse square law of light, and it's basically depends on the luminosity to how far light can travel before it eventually scatters. And light, even upwards, light will eventually scatter. There is no evidence that light can travel forever in any atmosphere.
All right, cool.
what will be the what will be the size of the Eiffel Tower from, what is it, 2,000 miles away?
Oh, it's way more than 2,000 from Boston.
What will be the size of it in your
Listen,
perspective?
It
What will be
doesn't
the
matter.
size of
because-
it? Yes, it does.
No, it doesn't. I'm saying
Oh,
if you
really?
rise from, if you rise from Boston, okay, and you have the Eiffel Tower lit up like a Christmas tree, because we can see, we can see the fucking shit from space. We see it from space, but you guys don't want to get into that. So we'll just stick with my little fucking fill thing here. The bottom line is this: there should be an angle, which he already stated. The higher you go, the further you can see. Okay, well, how high do I got to go to see fucking real far over to the other side?
And like I said, it depends on the luminosity of the light, because light can't travel forever. Eventually, it will scatter.
I know, but okay, listen, I'm not talking about weather. I'm talking about what is the height mathematically. You guys should be able to do a math problem right now, because the angle, all the fucking parallel lines and all the fucking other shit you guys are real fancy about. You should be able to say, okay, if I have this angle and I go up at a set altitude, I should be able to see said distance. What is it? That's all I'm asking you.
No, it doesn't work like that, because obviously atmospheric
course it
conditions are different. Of course. So if you do it in
That
the
has
day,
nothing to
you'll
do
have
with
a different.
atmosphere.
Can you
Your
please
geographical
stop
places-
clipping,
the
dude?
argument.
You sound ignorant when you clip all the time.
But they're geographical spots.
You're
That's what they do
so
with it.
excited and triggered thinking that you're right, and you can't understand a simple explanation of the atmosphere is more dense. And sometimes you can't even see 3 miles, much less 3,000 miles because of the atmosphere. And you can't understand that simple
No, because you have it wrong. It has nothing to do with weather or cloudiness. They're geographical locations. Boston is somewhere, said somewhere, degrees north, degrees south. It has a position. Paris, France has a position. It doesn't matter. if
Calm
it's cloudy.
down, dude.
I'm
Slow
talking
down.
about-
You're going to have a heart attack.
No, I'm fine. I'm sorry. I get excited. But I'm saying
We can tell you can't even listen.
No, you're not listening. It has nothing to do with
I've
atmosphere.
heard you, bro. You're
Times.
now repeating. I've heard
There's
exactly what you're
geographical positions that have measurements.
Heard
should
you.
be able to
Heard you.
do the math.
Heard
to get the
Relax,
angle.
relax. We don't. Okay,
Guys,
You
everyone
have to
stop.
calm down, bro.
Everyone stop. We got this shit on stage. I'm gonna find out how many channels so we can make a channel. Too much.
We don't need a stage channel
Right.
to explain to a man that you have density of atmosphere. And then he's asking us, yeah, but at this coordinates, at this angle, at this height, why
Yeah.
wouldn't you be able to see over this distance? Because you're
No,
I
I'm
know
not
why
saying.
he's
No,
asking.
I'm not saying that. Nice try. No. You're not gonna get out of it like that.
I know
I'm
he
not
clicked
saying that.
again. You got
I'm saying.
Rob, chill out. Rob, chill out. I know what you're asking, and I know why you're asking it. You're asking it because you're saying, okay, if the sun's in the sky, then we're not suffering from the atmospheric conditions at the ground level, so we should be able to try and determine or figure out how far the sun is. I get it. But what you're not taking
No,
into
that's not what
account
I'm
is-
saying at all.
You're acting like looking up.
I'm
we
not
are
saying that at
able
all.
to.
I just told you I'm not. So why would you tell me I am when I just told you I'm not?
Because you're talking about angles, and you're talking about the angle
Okay.
to the sun.
Okay.
Okay? And
No, I'm
Yeah.
not talking about the angle to the
but we
sun.
don't know. My
You're
point
just
is
adding
we don't.
stuff. I'm not saying any of
Listen,
it.
we can't make these predictions because we don't know the luminosity of the
They're
sun. We
not
don't know.
predictions. It has nothing to do
Rob,
yo,
with
Rob,
I don't. Hold
Rob,
on, man.
Rob.
I got it.
You're not
I
letting
got
me
it.
get it out.
Rob, I don't want to. Hold on, I got this, guys. Rob, I don't want to mute you, but I'm gonna have to because you can't.
I'm sorry,
you can't
Jeremy, but he's going
I
off
don't
and saying
know.
things
It's
that
not.
I'm
I'm
not
sorry,
saying.
but you just can't. You just can't clip people, bro. You got to go one at a time, or it's unlistenable.
I know, I understand. Sorry.
All I wanted to bring up was the standard candles model. Regardless of atmosphere, light cannot travel forever, but you need to know the luminosity of the light to be able to make any kind of prediction of how far or any kind of distance claim. Does that make sense? So we can't do this without knowing the luminosity, without knowing these things. But
Okay,
light
again,
can't travel forever.
Okay, cool. That has nothing to do with light traveling forever. Has nothing to do with anything you just said. You're just adding new stuff in to try to confuse people. It's a real simple concept. Boston is at a set position on the Earth. Paris, France is at a set position. If I want to see Paris, France, which we know we can't do, you said you have to go higher to see further. Now, math doesn't care about cloudy days because it's going to give you a mathematical answer. The height, the number you're going to have to go to see said distance down. Okay? That's the way it works. There's nothing around, no way around this, dude. You can try to fucking do what you want and dance around it. That is a fucking simple factual question, even for flat Earth. You can't do it. You can't do it because you know damn well as soon as you go high enough, you're going to see the globe and see the sphere.
There's several reasons why you're not getting it. You're not going to see that far because of angular size. You're not going to see that far because light can't be resolved from that far away. So eventually, everything will haze into the atmosphere. Even when you're up high, especially if you're looking down onto the Earth, well, then eventually you are in the atmosphere. So, Rob, you can't do that. You can't make those claims. You've got to take into account all of the atmospheric
Right.
and all of the perspective effects.
We're trying to get you to consider a couple principles here, right? Roots brought up angular size, right? You have angular size, angular resolution, light diffusion, attenuation. All these things, bro, are reasons why you couldn't see infinitely, even on a flat Earth.
No one's talking about seeing infinitely. This is a math problem, dude. It has nothing to do with actually saying, oh, I'm looking down from 150,000 feet and there's Paris. No. Okay, that's not what I'm saying. I'm saying there is an angle. There's a point where the angles will meet mathematically, and I want the number.
Rob, all right, so look up where Boston is, right? What latitude, how far it is from the Eiffel, how tall the Eiffel Tower is, their elevations, right? And then calculate what angular size would the Eiffel Tower be from Boston. Or if you increase your 1,000 feet, how big would you expect the Eiffel Tower to look?
Eiffel Tower has a location, okay? It doesn't matter if it's the size of a nickel or a dime. If you can pinpoint that location and measure from that location, that's all that matters. Again, you're trying to wake up and say, oh, even if you get that high, Rob, you can't look across there and see the Eiffel Tower. That's not the point. The point is proving this mathematically on a scale, on a model. You can't do it.
Rob, it'll be too small to resolve. Once you get so far,
Irrelevant.
when you're in math class, art class, and you drew things into perspective, you drew some lines into a convergence point, right? As you go down that line to your convergence point, things get smaller and smaller and smaller until eventually they start merging into one. Everything becomes a point. And this is your problem. You can't resolve things that are beyond the limit of how far we
my
can see.
That's absolutely absurd. What a crazy thing to say. First of all, there's no size limit to a geographical spot. If I know if I'm at 40 degrees, 0.00 whatever north by 34 degrees, 0.00 south, that is a geographical spot. It doesn't matter if it's the size of a
I
fucking
agree.
a
I agree,
ladybug.
but you
Okay, I
can't
can
see
find
it.
that spot. I don't need to see it. I'm not talking about seeing it. Again, it's not about atmospheres or seeing with my physical eyes. Yeah, what? Listen again. It's from measuring from that point up to the point where I can meet it above Boston. It's called using, right? You guys use all the instruments, sextants, and all these other crazy things you guys use. You can do this. You can measure this, but you guys can't because you don't want to.
I think you've moved the goalposts a bit there. I think we were talking about being able to resolve things over long distance, be able to see things. Now you're moving it to, does this physical location exist? This is a completely different subject.
Yeah, because no, it's not. It's the same one. You're just trying to run because the Eiffel Tower has a physical position. Okay? And okay, when I'm saying when you get up to there, the physical spot should be able to be seen. You're still going to be able to look at France and look towards Paris and see the actual continent or the country of Paris. Okay, we all agree when you get higher, you can see things. I've been up playing 30,000 feet and seen a lot of shit. So obviously, if you go higher, you're going to see more, right? I mean, we all agree on that. The higher you go, to see more. That's what he said earlier.
Yeah, it doesn't matter. You still have a limit to how far you can see, and everything will converge into your convergence point. It's still the same situation. It doesn't matter how high you are. Even if you're above the clouds,
What are you talking about?
the clouds will rise up into your convergence point. I mean,
We're
that's
above
a
the clouds
proof in
at this
itself. We're
point.
not
We're
on a ball.
above the clouds at this point, dude. We're talking like real high, like hundreds of thousands of feet, if not a million feet. We're not a million feet. How far do we got to go
Right.
to the continent?
So those clouds, Rob, those clouds.
How far do I have
Listen.
to go? I can look down and see.
Hold on, real quick. Let me just address this point, Rob. Think about like a AA battery. You know the size of a AA battery, right? From 10 feet, you could see it, right? But if I put that thing at the end of the football field, it gets harder to see. And then if I keep on moving it further and further, it gets harder to see because it's a small object, right?
Yep.
Yeah, okay. And it's not due to the obstruction because the earth is curving that I can't see that, right? Because if I put that battery a mile away from you, I could even put it, 6 feet above the surface for you. You're not going to be able to see it, right? You don't see things a mile away, right?
Oh, well, maybe not with it. Well, if I have a camera set up, I can, but not with my physical eyes. But the funny thing is, this one's gonna hurt you, man, because this is really bad. You brought it up because the bottom line is, if I register the coordinates of where I put that battery down, okay, no matter where I go in the world, I can bring that coordinates up and know where that battery is specifically, the exact position. I don't have to look at it. It's called instruments of technology, things you can use to figure this out. As I'm saying, you have to these. I don't know if you don't remember they don't exist or whatever, but yeah, you can do this. I know where that battery is, no matter where I'm
Okay, how about this, Rob? You're driving down the road, right? And there's cars super far away from you. Can you see the valve stem on their tires where you enter the air into the tire?
Well, am I behind them?
No, let's say they're like on the side of you and they're, hundreds of feet away. 300-400. What I'm trying to get at is when things are small in the distance, they're hard to see. You don't agree?
Yeah, again, we're talking about being able to physically see the Eiffel Tower from a million feet above the surface. I'm saying I can look down at Lycée Paris, France, and have it lit up. You know what I'm saying? You'll be able to look down and see it. At what distance can you do this? At what distance do I have to go to see the country of France?
Rob Knox, you start off on a false premise right there. You said from a million miles above the surface of Earth or a million feet. Nobody can do that. Nobody can go a million feet above the surface of the Earth.
Okay, well, my premise is not false. It's just an inquiry on how high we can go until we can see France. That's why the whole premise was how he said the higher you go, the more you can see. Well, I want to know how high I can go until I can see everything.
Okay, that's an interesting question, but honestly, what do you think the answer is to that question? How high can you go until you can see everything? How about on the globe? How high can you go until you can see everything on the globe?
Well, you'll never see everything on a globe because there's always a side turned away from you. Nice trick question.
Okay, so how
You
high
will
do you
always have a
go
limit.
until you can see 50% of the globe?
You can go to the moon and look back like we did.
How high is that?
The moon is like 238,000 miles away. I believe.
Okay, how do I get 238,000 miles above the surface of the Earth? Like me
Who says,
personally.
who says it's above the surface of the Earth? Like, that's what I'm saying. Your whole idea is just wrong, man. You just have it all wrong.
So you
Wow.
believe that if you're 238,000 miles above the Earth, then you're going to be able to look back and see 50% of the Earth? Are you going to be able to make out the continent?
How do you know they're not under the Earth?
Hold on, Rob. Are you going to be able to make out the continents from 238,000 miles away? Like, could you point to Hawaii from 238,000 miles above the surface of Hawaii?
I can see craters on the moon from 238,000 miles from Earth. Yeah, that's how it works, man.
Okay, so
See-
you think
see-
at the moon? Go ahead, Bruce.
I was just going to say, see, this is his problem. He thinks he's looking at light from millions of miles away. So in his head, he doesn't see the issues with his assumptions. And this is the problem. If you just stick to the convergence idea, the two train tracks, you can differentiate the two train tracks. But as it goes into the distance, they eventually merge into one. And this is really
They
the
never
issue.
merge. They never merge.
They merge, they appear to merge from your perspective because you have a limit to how far you can see.
No, because
And
yours
as things
curved.
reach your horizon, just before the horizon, there is like a depth zone. I can't remember what it's called, but everything compresses and squashes to a point where now you can't really tell the depth, the distance. Like a lot of information gets squashed into a small amount of space. This is what happens when you view out at the limits of your horizon. And you don't believe that because you believe you're seeing light from millions of miles away. That's the problem we have here. We have no proof that light can travel forever. That's why I was talking about light can't travel as far as millions of miles
Well,
without
93 million
scattering.
miles, but 93 million miles is not forever. You keep saying forever. No, it's not. 93 million miles is not forever. It's a number. It's 93 million. That's what it is.
Right, but we have no way to validate that. We have no way to believe
Oh my gosh,
that.
they actually
You
have.
only believe
They
that.
bounce radio signals off the sun itself that were encrypted and sent
Dude,
themselves.
you have got to
16
show
minutes
more
later.
intelligence and quit clipping.
It's 16 minutes. It takes 16
Why
minutes to
do-
learn that.
Why do railroad tracks appear to merge together? You said Earth curve?
Yeah, man.
Earth curve is why they merge together left to right for perspective
Yeah,
view.
and I can prove this. And I can prove this, man. If you take there's a
Oh,
picture.
my
There's a picture
God.
of a highway. Hold on, man. There's a picture of a highway in the west of the United States, and it's a giant. It's one straight highway that goes on for fucking like 50 miles straight. You can see it, and it's in a valley. So when you come in the valley from the top, you can look down at that giant like road, and it never converges, even though it's fucking 50, 60 miles long. It doesn't converge because it's just, you're talking about like perspective of like art and shit, vanishing points and shit. That's all to do with art and shit. It doesn't exist.
No,
in the real
I'm
world.
talking about driving a half a mile away from my house right now, looking down a railroad track and it appearing to merge towards the center. You're now saying that's due to
Okay.
Earth curve?
Yeah, man, that's the way it is. Yeah.
I'll talk to you later, man.
So why, when we zoom into that point where they've converge, why do they then separate? And now we see further down the track, and that convergence point is pushed back. How do
I
we
can
do that?
answer that. I can answer
Yeah.
that because we live on a curved Earth, and that's how it works. So obviously, that it's due to curved Earth.
Oh, stop it! Don't get all pissy about it. That's just my opinion, man.
Dude, what you're saying is ridiculous, man.
I mean, I'm sure it sounds like it's
It's
deep. It's the best I got, and it's what I do, man. I mean,
It's been
you
debunked though,
sound,
Rob.
you sound
This was
crazy to me.
debunked
No,
in
it
like
hasn't.
2015. Black Swan.
You never
Done.
debunked anything. That's what I'm saying. No matter how dumb I am,
That's a
always
ridiculous
heavy.
statement. That's a ridiculous
No.
statement.
I could come in here drooling, and still I'm gonna be right. To say the Earth's a globe, I'll be right.
You just disagree with every glober on your sphere Earth when saying that railroad tracks appear to merge together, and the only reason they do that is because you're on a curved Earth. That is just not true.
Well, I want to be FG2. You know, even
Yeah,
you guys
you're
no longer.
special.
Yeah, that's right here.